Alright, so looking at the calendar, we switched these 2 days. So law of cosines was yesterday. Today is application problems, which is, a fancy way to say word problems. We're also going to switch Wednesday and Thursday so that we get area of triangles before the seniors say adios for a week or so. And then Thursday, we'll do more word problems and start the review and review, and then not test till next block day. So tomorrow will be the last new day of stuff. After that, it's just practice and word problems and stuff, because our seniors will be out for most of those days. So you guys watching at home, it'll be clear what's assigned when, and you can kind of just keep pace on your own. Some of you guys are seniors at home anyway, and you'll be doing the senior activity stuff. So enjoy that, but don't get too lost, and know that we still got a pre-cal test next Wednesday, Thursday. All right, let's start by going over some of the law of cosines problems. So remember, it's worksheet 4, so a little bit out of order, but that's okay. They're all law of cosines, so I don't have to worry about which law to use yet, but we've talked enough about that. I'll say it one more time. If you can use law of sines, use law of sines. If there's an angle side pair that you know, use law of sines. If not, then you got to use law of cosines. So looking at worksheet 4, and maybe especially considering that I think the odd ones are posted, the even ones are not. So I'll work anything you got a question on, but I'd kind of rather work an even one because you already have access to the odd ones. Number 12. Due to prevailing winds, a tree grew so that it was leaning 4 degrees past vertical. So vertical would be straight up. 4 degrees past it means it's tilted by 4 degrees. So that's probably even more than 4 degrees, but it's tough to draw an angle so small. So it's tilted past vertical, so it's not straight up and down, it's 4 degrees past that. At a point 35 meters from the tree, the angle of elevation to the top of the tree is 23 degrees. Find the height of the tree. So 35 meters from the tree. So 35 meters from the tree. The angle of elevation, that's if you're standing over here and you look up at the top of the tree, the angle that your eyes have to look through, that's the angle that your eyes elevated. Your eyes looked up. That's the angle of elevation that they're talking about. So we're looking for that angle right there. No, that angle is 23. We want to know the height of the tree. All right, I don't have an angle side pair yet, but if this angle is 4 degrees, if it's 4 degrees past vertical, then what's this angle right here? 86. Now I'm getting somewhere, which means I can now learn this angle up here. 180 minus the other two. 71. And now I have an angle side pair. So this was on the law of cosine sheet, but this turned into a law of sines problem. Sine 71 over 35 equals, we want to know h, so let's do this pair. Sine of 23 over h. Cross multiply. And I'm out of space, but I can go to the calculator now anyway. 35 sine 23 divided by sine of 71 14.464. So I'm not sure if that was supposed to be a law of cosines problem somehow, but it ended up being law of sines.
How do we tell which way the 4 degrees goes?
That's a great question. It doesn't say. Did you do it the other way and get a different answer?
No, I was just wondering, because since it says past vertical, I think that it would be going 94 degrees.
Yeah. So that's a good question. The question is, how do you know the tree is leaning that way rather than leaning the other way, where this would be 94 instead? And then all the other things are this, well, not the same, because now this angle is different. It's not 71, it's whatever it is. So yeah, we would get a different answer if we leaned the tree the other way. So that would be the one problem with some of the word problems, is they're not clear on, well, which way is the tree leaning. Is it leaning toward the viewer or away from the viewer? And your question about, well, past vertical, does that mean it's, I was thinking this way, so it went past vertical that way. But if you're over on this side of the tree, then past vertical would be that way. So it's a good question, and this is one where I would take either answer. Whatever H you got out of this, I would accept that as well. 180 minus 94 minus 23. 63, and so it would be sine 63 over 35. So yeah, you would definitely get a different H for that.
Good morning, Mustangs. At this time, all English 1 EOC testers should be...
Let's look at number 4. Triangle GON, G-O-N. Let's see. G is 8, N is 12, O is 3. Which angle would you like to find first? You got a preference? Doesn't really matter. We'll just do G. It's first on the list. So if I want to find angle G, that means I need to use the, looking for space to write here, I need to use the equation that has cosine of G in it, which means I need the equation that has G squared on the other side. And maybe it's weird to write formulas like that, but that's how I do it with law of cosines, to make sure I get the right one. Angle and side have to be across from each other in the picture, and they've got to be across from each other in law of cosines. And then I'm not real worried about, well, who's A and who's B and who's C, and should I rename them? No, if I got these, then the other two sides are what goes in the middle here. So O squared plus N squared minus 2O N cosine of G. So let's fill in the pieces. 8 squared equals 3 squared plus 12 squared minus 2 times 3 times 12 times cosine of G. So now is the algebra. This is the hardest part of the problem, I think, and just based on what students miss, is, you know, can their algebra 1 skills, are they where they're supposed to be? Can they move things around correctly? So fraction bar, probably a pretty good choice for this one. Make sure we don't mess up parentheses. 8 squared minus 3 squared minus 12 squared, or negative 2 times 3 times 12. Oh, it even spit back a fraction for me. Not that it matters, because what am I going to do with that fraction? Like, what am I going to do next? That's what the cosine equals, so how do I figure out the angle? Inverse cosine. Inverse cosine of answer. Uh-oh, I get an error. Because I had cosine of angle G was something bigger than 1. whatever 89 divided by 72 is, but bigger than 1. And this is kind of the same error that the sine thing gave us. Cosine also is supposed to stay between -1 and 1. So when you ask the calculator, find me an angle whose cosine is 1.2, well, there's not a place where the cosine is equal to 1.236, because it never gets up that high. So this doesn't work. This is no triangle. We didn't do an example that happened like that yesterday. But if you look at those side links, one side's 12, the other sides are 3 and 8. Think about trying to build that triangle. So there's 12. Let's go 3 from this side and 8 from this side. Even if we lay them completely flat, the 3 and the 8 aren't going to touch. They only make 11. They're never going to get to 12. So this was kind of a weird problem because you could never make a triangle with sides 3, 8, and 12. So you'd have to really be paying attention to catch that initially, but hopefully you could make sense of it once you started down the path and got a no triangle situation. So that was a good one to pick because it didn't really work. But we also got to do a little bit of the algebra of it, so that was good to see.